Hello friends, so we're going to talk about complex fractions in this video. And what are complex fractions? So they are things that look like this. So let's kind of unpack what we're looking at here. So this first case is really like a fraction over another fraction. So it's like a giant fraction with multiple fractions in it. This is a case that we've talked about in other videos, and I will just quickly review it here. And the more interesting, I guess, type of complex fraction would look like this, where I've got multiple fractions over multiple fractions. And so we'll spend most of the video focusing on this, but we'll talk about everything with complex fractions just to cover our bases. So first of all, some complex fractions, they're really just fancy looking division problems in disguise. So for instance, this one, I've got a fraction over another fraction, and I've explained this in detail in a previous video. So when I have just one fraction over another one, really all that is a division problem. So I've got really 2x over x plus 5, so that is being divided by the whole denominator, 2x over x squared minus 25. And I want you just to appreciate when I wrote this out. So I just took this as is. So basically, this bar here, I just rewrote it as a division symbol. So sometimes I see people get a little confused with this and they try to flip the second fraction. So you're not even being asked to do that. So just restating this, I rewrite everything as it is, but I replace this bar here with the division sign. And then if you're familiar with division, then you know that you can just flip the second fraction or multiply it by the reciprocal. And so really this problem here is this multiplication problem in essence, right? So I think actually this is a great warm-up for this video. And, you know, I'm a big fan of saying math is not a spectator sport. So just to get yourself warmed up for today's lesson, maybe finish this one and hit play when you think you've got it. So to finish this, this one's nice and straightforward. So I've just got x plus 5 over x minus 5. So I just factor that. And then I cancel out. So these 2's will cancel out, and these x plus 5's will cancel out. So in the end, I'm just left with x times x minus 5, and it's up to you if you want to distribute that or not. Okay, so that's one type of complex fraction, one fraction over another. So what makes this particular fraction, complex fraction, what makes it different from the first example? So in other words, I'm asking you to compare this example here versus what we were just working on. And so if we take a second to appreciate this, so the thing I noticed with the first fraction is that I have like two fractions on top and two fractions on bottom. So I have multiple fractions here versus this second one, I have one fraction over another fraction. So it's this idea of having multiples versus one over one. And when you start to have multiple fractions, this gets a little bit more complicated into how do you actually simplify this. So at this moment, I just want to take a quick moment to remind you. So if you're playing along at home here, the way to get the most out of these videos is to absolutely pause when you need to, write things down, and to try things yourself. You know, I kind of just go through this video with the assumption that you are hitting the pause button. So please make sure that you're actually doing that and that, you know, you really try to engage with this so that you get the most out of this. Okay, so now what I want to do is I want to talk about how do I simplify this complex fraction? What do I actually do? And I want to outline the steps of how to actually do this. And I would strongly recommend that you write these steps down. So pause and write these steps down, just because you're more likely to remember it if you actually write out sentences of what you need to do. Okay, so the way that I simplify complex fractions is first I find the LCD of all fractions. So what I mean is I've got this fraction, this fraction, this fraction, and this fraction. So taken together, what is the LCD of all of these? And hopefully by this point, you're pretty strong on finding your LCDs. We've done that a lot in some previous videos. If not, I would recommend just going back and trying to brush up on your LCDs a little. So in this case, my LCD is 6. Okay, so that's step one. Find all the LCD, or find the LCD of all fractions. Second, multiply every term, or sometimes I say part of the problem, by the LCD. Part is not a very mathematical word, so if there's a math teacher watching this, they're probably going to want to slap me on the wrist. But I find that a lot of students like the idea of like a part versus using the word term, but they're tomato, tomato. So basically, anything that's being separated by a plus or minus sign needs to be multiplied by the LCD. So I want to show you what does that look like. So I have my LCD of 6 and I have this problem. So here's what it looks like to multiply every single part of that problem. So here's first of all the logic behind this. So first of all, really what I'm doing is I'm multiplying. So remember, this is in essence a giant fraction, right? There are fractions on top and fractions on bottom. But in essence, this entire thing is also a fraction. And so what I'm doing is I'm really multiplying the top and bottom of this fraction by 6 over 6. And in doing this, by multiplying by the same thing on top and on bottom, I'm really, this whole thing right here just equals 1. So I'm not changing the value of the fraction. Remember that whole idea of whatever I multiply by the top, or whatever I multiply on the bottom, I have to multiply on the top. I'm literally using that principle here. And now what I'm going to do is I effectively distribute these 6's into the top and the bottom. So here's what it looks like then to actually take the LCD and multiply all of this. And this is usually what you're actually going to write down. You don't usually have to do all of this unless you find this helpful to have this like visual of why you're doing this, then you can write this down. But most people, when they write this down, they just go straight to this step here. So notice what I've done here. I've taken each part of the problem or term and I've multiplied everything by that LCD. So you can see I've multiplied it 1, 2, 3, 4 times. Okay, and so now from here, we're actually very close to being done. So the point of using the LCD in this case is to actually get rid of having all the fractions. So let's take a look at the process of how do I get rid of my fractions now. So what I'm going to do is I'm going to say, well, how many times does 2 go into 6? 2 goes into 6 3 times, or what is 6 divided by 2? You can do the either way. Okay, so notice what I'm left with. I've canceled out the 6 and 2, so now I just need to multiply the 3 times the 1. What is 3 times 1? It is 3. Okay, so we're done with that one, all right? Let's do it again. So now, how many times does 3 go into 6 here? It goes in twice. Okay, and so now look at what I'm left with. I am left with 2 times 1. So this is going to be minus 2. The top is now done. So now we're going to pivot to the bottom, all right? How many times does 6 go into 6? Just once. So look at what I'm left with. 1 times 5. 1 times 5 is just 5, so I'll write that down here. And then finally, I have how many times does 3 go into 6? It goes in twice. So what am I left with? 2 times 1. What is 2 times 1? It is 2. So in multiplying everything by the LCD, look at how much simpler it made this problem. And now I just have to finish the math here. So 3 minus 2 is 1, 5 plus 2 is 7. So my answer here is 1/7. And so this is the idea of using this technique. Okay, so I want you guys now to try this one on your own. The first thing, let's do this in steps together. So I'm going to encourage you to pause along the way. So the first thing that I want you to do is I want you to write down what you think the LCD is. And then I want you to just set up what it means to multiply every part of this problem by the LCD. So don't go any farther than that. Just set that up. Hit play when you're ready. Okay, so in this case, I've got 7/9, 1/3, and 5/9. So the LCD among all of that will be 9. And now I just want to show you what does it mean to multiply this 9 by every single part of the problem. Okay, there are 1, 2, 3, 4 things in this problem. So notice that I've multiplied 9 4 times. So one thing I want to point out here is I know that this 1 is not a fraction. So remember, my instructions were to multiply every term or every part of the problem. I didn't say just multiply the fractions. So even though this isn't a fraction, remember, we have to keep this whole equation balanced, so everything has to be multiplied by the LCD, or we actually change the value of the problem. So make sure that you have this. The next thing that I want you to do is I just want you to do your cancellations like we did in the last one. So go ahead and try that and then hit play when you're ready. Worst that happens is you get it wrong, but you'll learn a lot more if you try. Okay, so I'm going to go through this. So 9 goes into 9 once. So I'm left with, so notice I'm left with the calculation 1 times 7. So 1 times 7 is 7. Okay. 3 goes into 9 3 times. So I'm left with the calculation 3 times 1. So this will be minus 3. And now we're done with the top. 9 times 1 is just 9. And then for this last one, so 9 cancels out with 9, and so then I'm left with 9 plus 5. Okay, so now I need to finish my math here. So this will be 4 over 14. And then this fraction can be simplified to 2 over 7. And so now we're good to go. So you cannot do cancellations until you get to the very end. So when you've added or subtracted or done all that, once you get to this step, then you can decide if you can simplify more. Okay, so I have more examples on just doing this with numbers. So if you're feeling like you could use a few more, please feel free to check out those videos. But I want to now move on to having a few more variables. So let's look at this next example here. So this is still going to work with the same logic. So let's walk through this together again. So once again, I want you to find the LCD and then just set up what you think the multiplication of the LCD will look like. So go ahead and do that. Hit play when you're ready. Okay, so in this case, my LCD is just x times y. So let me show you what it looks like to multiply this LCD by every single part of the problem. So if I set that up, notice now I've had 4 things up here and I've multiplied the LCD out 4 times. Okay, so now what I want to encourage you to do is just do your best to finish this problem. I know it's a little different with the variables, but give it a try. And hit play when you think you've got it, or if you're stuck, worst that happens is you get it wrong, but you'll still learn something. Okay, so now I'm going to go ahead and I'm going to cancel out these x's. So notice what I'm left with. I'm left with 5 times y, so that's just going to be 5y. And then moving on to the next problem, see the y's will cancel out, so now I'm left with x times 2, so this will be plus 2x, and that's all I can do on the top. Okay, so now the y's are going to cancel out, so I'm left with x times 1, so that's just x. And then for this last one, so I have the x and the x drop out, so now I'm just left with y times 3, so that's going to be minus 3y. Okay, so now that I've done all that, I actually can't collect any like terms, so this is as far as this particular problem goes, so we're all good. We can keep moving on. Okay, so here's another one for you. We've got just slightly more complicated variables, I guess, or polynomial bases or whatever. So I actually think that if you're feeling confident, go ahead and just try this thing all the way through. And if you're stuck, I'll kind of lead you through the pieces. So once again, just start at least by finding your LCD and setting up the multiplication, and hit play when you've done that, just to check where you're at. Okay, so in this case, my LCD is going to be x plus 3 times x minus 1. And so I have these 4 different parts of the problem. So I'm going to go ahead and multiply, which just like explodes in complexity, I see. But so here's what I am left with. So what cancels out? So in this case, the x plus 3's will cancel out. So I'm left with 6 times x minus 1. I'm going to write all this out on another slide or on another page because I'm running out of room here. So let's just make sure we've got the cancellations right. So I've got 6 times x minus 1. Then for this next part, so this is going to be the x minus 1's drop out. Moving down here, the x minus 1's drop out. And then here, the x plus 3's drop out. Okay, so we can now see I should have this 6 times x minus 1 minus 4 times x plus 3 over 2 times x plus 3 and then plus 5 times x minus 1. So just writing out what's left, we've got this. Okay, now you might remember in other videos where I've talked about not being cancellation happy, and this is one of those times where we do not want to be cancellation happy. So the next thing that we need to do is just distribute and collect all of our like terms. So if I do that, this is going to become, let me change my pen color. So this will be 6x minus 6 minus 4x minus 12 on top. And in the bottom, I have 2x plus 6 plus 5x minus 5. Okay, so I'm going to collect any like terms. So let's see, that's going to become, so 6x minus 4x is 2x. Negative 6x minus 12x will be negative 18x. And then on top, or I am like all messed up here. Okay, 2x plus 5x is 7x. And then 6 minus 1 will be plus 1. Okay, cool. So the only thing that I can really like factor out here would be like a 2 on top. And I don't really need to do that because technically this is just as simplified as this. So these are equivalent, but I guess this would be more simplified. And so that's all we can do for that one. All right, so this last one is definitely the trickiest of them all. So I really actually want to encourage you to try this totally on your own. And, you know, this is your first time learning this, so this is a really great challenge problem. And the worst that happens is you get stuck, but try this on your own. Let's see how you do. It's tricky. If you start to feel like you're getting stuck, you can always watch the video. But, you know, math is not a spectator sport. You learn best by doing it, so give it a try. Okay, so looking at all my denominators, my LCD is going to be t plus 5 and t minus 5. So I need to multiply every single part by that LCD. So here's what that looks like. Okay, so in this case, so there's nothing to cancel out here, right? So this is actually just going to end up becoming t squared minus 25. In this little grouping here, let's see, I can cancel out the t plus 5s. Down here, actually the entire LCD will cancel out with the denominator. And then here, the t minus 5s are going to drop out. Okay, so what is actually left for me to multiply out? So I'll just show you because I wrote this out already. Okay, so here's what's left after I do my simplifications. Okay, so if you made it to this point, awesome. And if you got stuck, so remember, we don't want to be cancellation happy. We can't cancel stuff out yet. Just go ahead and multiply everything together and see what you get. And I will tell you there's a little bit of a twist to this problem. So try to find that twist, you know, see if you can figure it out. Okay, so let's see. This right here, I know is just going to end up becoming, wrong pen color again. This will be t squared minus 25. And then this will be minus 4t plus 20. Okay, so first things first, make sure that you actually wrote plus 20 on your paper. If you're playing along at home here. And then 4 plus t squared plus 5t. Okay, so let's collect our like terms and let's write everything in descending order. So this will become t squared minus 4t minus 5. Cool. And then this will be t squared plus 5t plus 4. Okay, and so what makes this fun, right, and interesting is that I can factor these actually. So let's factor. So this will be t minus 5, t plus 1. And this one will be t plus 4, t plus 1. And then, oh my God, it's so exciting. They cancel out. So those cancel. And so the final answer is t minus 5 over t plus 4. It's like so satisfying, right? It's like, oh, it's a lot of work, but yeah, it's cool. Well, it's cool. Like I'm cool at parties, cool, but okay. So this is the final answer. Okay, so I kind of went through some of the general ideas of examples. If you want to see either like slower paced instruction or you want to see more examples, I do have more videos on that stuff. So remember, you have to make your education work for your particular needs. That's how online instruction really works. So if you need more examples, go out and watch them. If you want to watch it explained in another way, check that out. And otherwise, if you found this video helpful, consider hitting the like button. I would love that. Or consider subscribing to the channel. I'm trying to provide, and I have been for several years now, just making high quality math videos. So any, you know, love that you give the channel, I always appreciate. You don't have to, but you know, it's cool if you do. And okay, so that is going to leave, well, what am I saying? I'll leave it at that. How about that? All right, I'll see you guys later.